Good afternoon, everybody. This is Mr. Henson here. We're going to be reviewing the scientific method today. Uh, this first 2 weeks, we're trying to figure out, based upon the PowerPoint, what do scientists do? So, scientists do a few things, but here's the method for how they do it. So, in my PowerPoint, the scientific method, okay, I said that there are multiple answers to the question, how many steps? So generally, you're going to have 5 steps, okay? But this is the basics. So the first step is to ask a question or make an observation. That is where majority of the scientific methods will differ in this first step here. So when you ask a question or make an observation, you're thinking in your mind, what are you curious about? What have you seen that makes you wonder, So that's the idea of step one. The idea of step one is what is in your mind and why. Step two says to write an hypothesis. To write a hypothesis is to pose an answer to your thought or your ponderance or your question before. So, what do you think is the answer to the question or the reason for your observation? Why did my ear hear a sound and I turned? That's an observation. So, what we're trying to understand is how we can anticipate an answer. Number three says make a prediction. So these sound very similar, but the difference is when you make a prediction, this is what are some of the if then statements that can explain and confirm your hypothesis. So if you notice, it says a if then statement. We're going to be dealing with if then statements constantly because we're trying to have what you call a pattern. Okay, that's what scientists is looking for. They're trying to observe the patterns of phenomena. And if these patterns of phenomena have a repeated cycle, then we can start to build a theory around them. For instance, the theory of gravity as we discussed during our Zoom meetings. Number four, perform tests or experiments. Okay, what will you do to test your predictions? What experiment do you need? What actions must occur in order for you to see if your prediction holds true to your hypothesis or solution to the question you once asked? Okay? So, what will you do to test your prediction? Your hypothesis may not have been correct, and that's okay. So, this says it's okay. In our class, we're going to call that falsifiable. Okay? Falsifiable is the ability to know you are wrong for a right reason. And finally, state your conclusion. What did your experiment actually show you? Okay. Did the experiment confirm your hypothesis or did it negate your hypothesis? In other words, did your experiment say, yes, this is true? You are correct. Notice I said two different statements. Yes, you are true is the first statement. The second statement is you are correct. And that is what we're trying to do as a scientist. Okay, at the most basic level, the scientific method is here to help us answer a question, to help us confirm an answer, to help us repeat that confirmation, to trial or try that confirmation, and to be honest and true to the results. Okay, we have a final action that says application. How does the information you found relate to your everyday experience? Now, this here is going to change, which is why the scientific method itself, this is why this is able to be changed. Again, there is a general understanding with the scientific method, and that most general understanding is observation, phenomena, conclusion. Those three facts. Step 1, Step 2, and Step 5. Those are the most general and the most translatable aspects to the scientific method that can be applied to anywhere and anybody. So that is the scientific method in a nutshell. I'm Mr. Henson.